believe it or not, this is a radio. This is a radio that I built based on a chip buried underneath here that I took out of a cheap and nasty portable radio that I bought. Now, out of that little radio, I got this chip, and was able to find a data sheet for the chip, and the data sheet suggested that not only could that chip do AM and FM, which both work on this radio for some definitions of work, not only could it do AM and FM, it was also capable of receiving just about every shortwave band one might want. And this resistor ladder is an attempt to implement the switch that would shift from one of those shortwave bands to the other. So on most shortwave radios you have a big switch. Well, that's done by this wire here. So you can switch from one shortwave band to the other. At the moment it's on AM. It was actually receiving. Let's see. Anyway, we might have something. It's quite difficult to tune for reasons that I will explain later. There we go. So it does work for some definitions of work. So this has been my project for the last couple of weeks to try to build a working radio out of that chip, to see, given that I had the data sheet and an example circuit, whether I could build myself a radio that would work. Now, a couple of things to say about this project. At the moment, it works. It will pull on FM and AM, provided one wiggles all the wires occasionally and mucks about with it. On shortwave, it's trying to receive something, but it's clear that the resistance is wrong. And if you read the resistance along this resistor ladder, there's so much resistance from stuffing it into the breadboard. There's 16 resistors here, 16 10K resistors here. So by the time you get to the end of that, it's just like it's all over the place. So I think what the next stage of this project is going to be to at least solder that part of the circuit onto a bit of perf board and see if that will make it work, or it work better, and see if, most importantly, whether I can actually pull in a shortwave station on it. I have tried a couple of times, and I thought I almost had something briefly, but at the moment that doesn't seem to be there. So just to point out the parts, so we have the chip, which is a digital signal processing receiver chip. It requires relatively little off-board stuff. It requires two 50K potentiometers. There's two. This one is a volume control, essentially. This is the one that came on the radio. I think it might be linear. It seems to be easier to tune than trying to use that one. I did have two of those on originally. This one may be logarithmic, or some variation of logarithmic. It's got a power supply section over here. It's got an antenna section over here that brings in the FM antenna and uses a couple of diodes to protect the chip from static discharge or something like that could get in the antenna. At least that's what I'm assuming it's doing. It's got a couple of LED lights which tell you which band it's on, well, it's FM or AM. Interestingly, they also double as the signal for the FM and AM switch. So that took me a while to figure out what on earth it was doing there. There's a crystal, which you might be able to see in here, that presumably provides the crystal for the chip. that's desoldered from the original radio. And there's a ferrite core antenna. So the ferrite core antenna, the chip, the crystal, and this volume control come from the original radio. Everything else comes out of my pile of not terribly good quality parts that tends to float around. Oh, the speaker as well. That's particularly nasty. I mean, the shocking thing about it is that it works at all, that you could implement that circuit and there you go, you've got a radio after a fashion. There are a couple of difficulties with this, some of which may be related to the breadboard. I've actually tried removing some elements of the circuit to see what might not be necessary. But so far, most of the original design does seem to be necessary. You can get away without the protection on the antenna circuit, for example. That would work all right. Obviously, until you hit it with a strong static charge, and then you're kind of dependent on those diodes. Yeah, so there's not much to say about it, but I just thought it was a fun project and it amused me. So I've recorded a fair amount of video. A lot of it's handheld and not very good in that regard of me putting this together. And I'm going to record some more video just in stages as I try to solder up. I'm actually thinking I can squish the whole circuit onto this one little piece of perf board. Reach over here, keeping in mind that the original circuit was that, right? So I bet I could fit it, the whole thing, on here. And so I might sort of recreate a pocket radio out of that on my own. But again, the goal is to see, can I get shortwave? And so far the answer is maybe it might be a little bit, but I'm thinking that soldering it up will make a big difference. So this mess has been remarkably entertaining to build, and I hope you enjoy watching me try to figure this out. It's been a bit of a trip. Well, that was a serious pain in the butt, but I now believe I have it correctly soldered into this little holder so I can put it on a breadboard. And that means that I can start building the circuit from the data sheet. So here is the first iteration of the radio put together on a breadboard. So I believe I've got it on FM here. And it is working. It is finding signals. Here is the antenna. And I did have some success on AM. But I think the problem is that the resistance in this long string of resistors changes. And both of these pots are connected to the end of the divider. So, while I can do some tuning, and I do actually think the circuit is working, there is some radio there. You know, it's not an effective radio, and I certainly can't try a shortwave channel or shortwave station if I can't tune AM properly. But I do think that the circuit is working. So I think the first step here will be to replace these resistors, or the ones that I don't need in order to get, say, FM working, with a single resistor of appropriate value and see if it works. If that works, then I think I'm going to have to solder those onto some perf board, which I have, and then take at least that part of the radio onto perf board and off of the breadboard. I don't think any of these power connectors or anything are going to be a problem, but I do think this whole, like these guys and all of this is probably going to have to going to be soldered, which does, lead to the question of whether it might be a good idea to, well, there I can get a better look at it, but it does lead the question is, do I want to rebuild the radio on perf board as opposed to on breadboard, which is the thought. But I do think at this point I have succeeded, at least so far, in rebuilding some of the radio. It's working. The chip appears to be working. As I said, I think that if the resistance was more stable throughout the whole thing, that it would matter. I don't think the capacitance matters. There might also be issues around this clock. I could try wiggling the clock and see if that makes a difference. But I mean, it's got to be working to some extent if we're getting anything at all. So yeah, so I think my plan is going to be to, and it's not going to be today, is going to be to simplify this whole resistor array so that it will be stable. And I mean, I do know that if you put a needle on, if you put a meter on the end of it, the resistance goes all over the place as you wiggle it around. So, and it's much higher than it ought to be. So I think the fact that it's working at all is kind of amazing, even, this is hardly working well. But, so that's, I think, so that's the first stage. Replace a bunch of those resistors with just a few, and next stage, consider putting all of those on a perf board with maybe some of these pins and whatnot to connect it back into here so that we have something to use as jumpers. Anyway, that's what I'm thinking, and I'm thinking the volume pots are also going to have to go onto the perf board. I am kind of tempted to rescue, not the volume pot, they're both 50K pots, so, but I am tempted to rescue the tuning one from here. I don't think this is anything special, but this might be. So I am tempted. These are just what I had in a bag of potentiometers I ordered at one time for some purpose. So we'll see. Anyway, so far this has been a really fun project, and I've really been enjoying trying to get this working. All right, I've decided to desolder the potentiometer. That's this one here that controls the tuning on this. I think that a lot of the trouble might be the pot there, and this one's obviously going to be a pain and won't plug right into the breadboard, but that one will, because it's got 3 legs over here, and then we've got just these 2 pins that hold it in place. So if I can successfully desolder this thing, it should drop right in without having to screw around with anything else, and we'll see if that makes a difference. Okay, there we go. Too much solder wick used, but it works as usual. And there we go. There's this potentiometer, and the pin spacing looks the same, so let's have a look and see how that works.
Just because hair salon owner Nicholas Nestor can now return to 100% capacity.
So there we go. There's FM working, sort of. It works better with this than with the other one. It's still very touchy, of course. So just to give you a little bit of an idea of how this is doing on FM now.
Disconnect.
So as you can see, we're here. You can, so we got, you know, maybe 10 stations coming in here. This is, I mean, Toronto, there are 40 stations if you have a sensitive enough FM radio. But this is the antenna. We're in a very noisy little corner of the house right now. And it's working. This did improve things a bit, but not that much. Wiggling the resistors does help. And I'm going to try it now on AM again, now that I've changed that potentiometer out, and we'll see. So a little bit more wiggling around and some adjusting of where I was supposed to plug it in, and figuring all that out again, hence the schematic underneath it. AM is now working very well. And you can see the power draw going up and down. It works. It just works. Yeah, not very well because it's not soldered, but it just works. Okay, it's a little after 6 here in Toronto. And you can see that there is a little shortwave available if you want to listen to preachers. Up on the band 4 on this little XH data. I'm using this radio because it tunes similarly, and I feel it's kind of similar to what I've got deconstructed here. So band 4 is, if you look at it on the monitor here, that would be shortwave 6, I believe. If we look over here, we can look up what the range is, and we want, yeah, so that's shortwave 6 over here, which means we need to connect it 1, 2, 3, 4 resistors below where you typically connect medium wave, which is where this is. So 1, 2, 3, and I need to go one more, and I should be on the same band. So just give me a moment. Sorry for the finger in front of here, and I will connect the antenna up to my antenna here, and we'll see what we get. Okay, so we're listening to a little AM here in the background, and I'm going to try to flip this down and see if I can get some shortwave. I tried before, and it turned out I wasn't filming. I'm going to try again. I should say, given how touchy this thing is to tune on AM, the likelihood of getting anything on shortwave seems low, but I do have a shortwave antenna connected here to my antenna. And give it, oh, there's a finger. We'll give everything a little bit of a wiggle and see if we can get anything in. Now, I should say, to connect it to, the strongest thing that comes in is, preaching just below 10,000 kilohertz, right? What is that, 99.92 or something like that. Anyway, so we will go down to what I believe is that range. So that involves going down 1, 2, 3, 4, 5, 6. So it definitely is changing what it's doing, right? So we'll go to what I think is the bottom of the band. There's something there. I think we can make the argument it's a shortwave radio. Not a good one, mind you. Yeah, that's right up against the edge of the dial, so that should be... Yeah, there's something in there. So I suspect if it was not just put together on a breadboard, that it would actually work. I don't think it would be a very good shortwave radio, but I do think it would be a working one. So as a kind of proof of concept, well, the question, can you pull the chip out of a cheap DSP-based AM/FM radio and make a shortwave radio out of it? I think the answer is potentially yes. There's a station. What's that station? And so we have a functioning shortwave radio. Now I should say at this time of evening here in Toronto, we have lots of potential stations available and not much is coming in, and you know the Texan is managing with the screen in front of the monitor and no external antenna to still manage, you know, well, I mean, that signal is so strong because there's a lot of noise around here, but there's still a pretty decent signal to noise ratio. And this is not doing very well, but it works. It is a shortwave radio. I have built a mostly breadboard shortwave radio that works, and I'm pretty happy about that.